Hi guys, okay, welcome to the second part of hypertonic, hypotonic and isotonic. Alright, this video I dedicated exclusively only for isotonic. Okay, you may wonder why in my first part I did not touch anything about isotonic at all. Right, there is a reason for it. Okay, in my experience, right, isotonic is actually a term, not only a term, it's been very much misunderstood, very much misused. All right, and students always find it very hard to apply this in questions. Not only that, a lot of horse questions, all right, a lot of horse questions comes out related to isotonic, and the students never know how to tackle them. So this video, I dedicated this video exclusively for isotonic so that you get a better understanding of how to use this term properly and to get the full mark for questions related to it. Okay, for the start, that's a good news. All right, so even though if it's isotonic questions related to isotonic, okay, the three mantras that I taught you in the previous part 1 still can be applied fully. All right, so if you remember, or you can always go back and watch my first video related to this hypertonic, hypotonic and isotonic. Okay, the first thing first is you must define the environment. All right, the second thing is you need to explain the diffusion of water by osmosis, where is the direction and so on. The third thing is you need to explain what is the consequences to the cell or the system once this osmosis has taken place. All right, so that will never change. We are going to stick to that script. Okay, just to jog back the memory, all right, so I've given you a question, all right, where a red blood cell has been immersed in 3 different types of solution. All right, the first one is distilled water. Okay, we have tackled the hypertonic solution and hypotonic solution in the previous video, so I'm not going to go into that, but just to give you an overview. All right, so a red blood cell which has been immersed into distilled water, which is a hypotonic solution to the red blood cell, so obviously they will hemolyze. Right? Okay, so when you immerse them into a concentrated salt solution, which is a hypertonic solution to the cell, so water will diffuse out of the cell by osmosis and causing them to crenate. All right, so that part we are done and over. Okay, so our video, our lesson today is going to be exclusively, we're going to focus only on isotonic solution. All right, so the isotonic solution to the red blood cell is actually 0.85% salt solution. Right, so this is where our lesson is going to be focused on. Okay, I've taken a slightly different approach. Okay, I am not going to give you the answer, but actually I've given you a sample answer by students which is actually wrong. All right, so please look at this the answers from a student. All right, so can you identify, using all the 3 mantras that I taught you before and we just discussed in the previous slide just now, can you identify what exactly is wrong with the answer of the students? You know, once in a while you take the role of a teacher to identify the mistake. Actually you will learn a lot. All right, okay, so can you identify this before we move on to the next slide? Okay, since you have digested the wrong answer, let's go into it. All right, okay, the first mantra. All right, so look at the answer of the student. 0.85 salt solution is isotonic. That's wrong, isn't it? Okay, so what will be the correct answer? 0.85 salt solution, percent of salt solution is isotonic to the red blood cell. All right, because I have emphasized in my previous video that isotonic, hypertonic and hypotonic are comparative words. All right, they do not stand on their own, they do not bring any meaning if you do so. All right, so you always have to compare them with the cell or the other system. All right, So the best way to write this is 0.85% salt solution is isotonic to the red blood cell. Note that. Moving on to our second mantra. Okay, look at the answer of the student. No diffusion of water. Oh, we have two wrongs there. Double the trouble. Okay. So yeah, there are two obvious mistakes here if you can identify them. Alright. So number one, this is where I want to explain to you. This is where the students always make mistake. Guys, please remember that osmosis involves water molecule. Alright, and water molecule are molecules with kinetic energy. Alright, even though they are in a system where both the systems are equal concentration, they are at equilibrium. Isotonic that is what is about. Okay, they have both reached equilibrium. That does not mean the molecule, the water molecule, will stay put at their places. No. They have kinetic energy. They will often move around here and there, here and there, here and there. But the net movement will be zero. Okay? The water will diffuse in and out equally. If two molecules go to the other side, another two will come back this side. Three molecules go to the other side, another three will come back this side. So when you plus minus, you get net zero. That is what they mean. Okay, but when you say there's no diffusion of water, you're trying to imply there's no osmosis has occurred. That is totally wrong. Okay, so that was the first mistake. The second mistake is, guys, please do not leave out the word osmosis. It's a fundamental word. You have to train yourself to always use the word osmosis when you're dealing with this type of question. Alright, sometimes in the marking schemes, these are all insiders' secrecy. Alright, but if you do not have the word osmosis, no matter how beautiful your sentence is, the whole thing, we cannot take it as your answer. Alright, we cannot give you award marks for that. Alright, so always train yourself to stick to this. Alright, always use the word osmosis no matter what. Okay, the third and the last mantra. Okay, look at the answer. Nothing happens to the cell. How sweet. No, it's wrong. Okay, how can you say nothing happens to cell? There's so many processes happen. There's so much molecules are moving about and so on. Nothing happens to the cell? No. The best way to write this is the cell remains the same. There will be no changes to the cell before and after being immersed into the 0.85% salt solution. That is the best way to write. Sometimes, guys, you guys are just so plain lazy. Alright? If you are my students, I tell you, you would get the look from me. Okay? You don't want to see that side of me. Okay? My students know. But then sometimes I pity you guys because oh God, I don't know how to say. But then alright, just leave it that. But then do not say nothing happens to the cell. Okay, that's hilarious. Alright, this is the part where the students hate the most nefarious part of biology, the horse question. But you cannot escape it. Alright, you learn to live with it. Alright. So the relationship with the students and bio is like Beauty and the Beast, right? So initially you will hate it, but once you get to know how to answer the questions, how to answer them properly, then you might love it. Actually, right? So that is what I always tell my students. The relationship between bio and students is like the Beauty and the Beast, right? Okay. Alright, okay, let's look at the question. A severely dehydrated patient is immediately given 0.85 saline water drips intravenously. Alright, so how does this treatment help the patient? So this is one question which is related to isotonic, hypertonic and hypotonic. Alright, so obviously in this case actually we have to see it from the point of view of isotonic. Alright, so what does it mean when a person is severely dehydrated? Okay, this means this person do not have enough water in the blood plasma. Okay, so if this is the case, what happens is the water will start diffusing out of the cells by osmosis instead of coming into the cells. Oh, that is very bad, because the cells will start losing water. So that is when we mean that the person is actually dehydrated. So if he's severely dehydrated, that means he cannot take the oral rehydration salt orally, because he's obviously blacked out. The system will shut down, one by one. Alright, so he has to take it intravenously. Alright, so the question is, how does this help the patient? Right? Okay, applying the first mantra, 0.85% saline solution is isotonic to normal human blood plasma. Okay, so the normal human blood plasma is approximately 0.85 to 0.9%, around there, alright? Okay, so when you administer this saline solution, that means you are trying to get back the human blood osmotic pressure back to normal, alright? That is what this means. The second step, water will diffuse in and out of plasma and the cells equally by osmosis, preventing loss of water from the cells, because initially when he was dehydrated, the water was going the other way around from the cells out into the plasma. To avoid that, so when you administer this saline water drips in it, so what will happen? The water will, instead of going out into the blood plasma, so it is going to become equal. So that is why we need to do this, to treat this patient. So what will be the final consequences to this patient? Alright, so the patient's blood osmotic pressure will return to normal, thus rehydration occurs, because initially he was dehydrated. So everybody is happy. Oh, what a beautiful ending. Okay, we are at the final part of our video today. Okay, but I'm not going to let you off the hook. Alright, I'm going to give you another additional nefarious sports questions. Right? Okay, an athlete is advised to drink isotonic drink right after sports. How does this isotonic drink help the athlete? Alright, okay, so please don't forget to use the 3 mantras. Alright, and you may submit your answers in the comment sections below. I'm not going to give you the answer. No. Alright, okay, so stay tuned for more videos like this. I'm going to help you with more techniques of answering questions. More of them are going to come out, and so subscribe to my channel, and see you the next time. Happy holiday, guys.